I want you to build 1 million of these boxes, and the only requirement is it has to hold 400 cubic inches. And it has to have this basic shape, and you can tweak the dimensions. You are going to try and find the way to do that using the least amount of surface area. Because you want to give these people the least amount of cardboard possible to do the job, because that way you can save money on the materials you have to buy. Someone gives you a check to make these boxes, you have to take that check, and you have to go buy the cardboard yourself, put it together, and the less money you save, the less profit you have. So anytime you are holding a box, there is somebody who was trying to figure out how to make that box with the least amount of material, so their company could save money. There are a couple of exceptions to that. They have figured out that some box sizes are so ugly, people hate them.
Put some paper in there.
Put some paper in there? Yeah, that's right. So that is number 32. Other questions? 40. Since today's homework is similar, might as well do them all.
Cool.
That one up a
Well,
moment.
I got most of it, but then I forgot or something. I don't know. No, it's all right.
Hey, who has to leave early on Thursday, speaking of which?
Not me. Wait, what's Thursday?
Yeah, I think so.
Okay, when?
I don't know.
2:50, I believe.
Okay, because that's when the test is. So,
Wait, so...
Really?
Okay,
Yeah.
wait, Thursday...
Can you cut it down for us?
I'll figure something out.
No.
40. Okay. Let p of x, pxy be a point on the graph y equals x squared minus 8. Very quickly. What does y equals x squared minus 8 look like?
Up, no, down, 8.
What's it look like?
Is it parabola that starts -8?
Smiling or frowning, Stephen?
Smile.
Excellent. It is a smiling parabola that begins down here. Just out of curiosity, where does this hit the x-axis?
Yeah, 250.
Okay, you guys will write your names, leave, and take it Monday, I guess. I don't know what to tell you. So, we're taking a similar one. Okay, just that, before I graph this, where does this thing hit the x-axis?
0, 0.
No, x squared minus 8. It's a parabola that's been shifted down. To find x-intercepts, quick review. Set that equal to 0. Add 8 to both sides. Oh my God, Stephen, I should hit you with a marker.
It's an annoying number.
X is plus or minus the square root of 8, which is plus or minus 2 root 2. Root 2, of course, as you all know, is about 1.4. So that's plus or minus 2.8.
Of course.
You guys can all do that about that quick.
The square root of 2 is 1.4. I mean,
About
common
1.4.
knowledge, of course.
Of course. People wake up in the morning just thinking, oh yeah, square root of 2, 1.4. You guys can find zeros of parabolas about that fast, right?
About.
Good.
No.
Okay. So this is what it looks like. Now, let pxy be a point on the graph. Express the distance d from p to the origin as a function of the point's x-coordinate. This is one I was really hoping to have time to do the example of.
Is your other class taking a test somewhere there? Or are they taking it Thursday?
Everybody's taking a test Thursday from me.
I think I have 3 tests that day.
Okay.
Does that mean that...
It's 4.
All right, can you guys see this little d up in here?
Yeah.
Okay, this is the distance from the origin to any point on the graph. This point can be here, this point can move up here. We want to express how the distance changes as long as the point stays on this parabola. Okay? We want to express how far a point on the parabola is from the origin, bless you,
Then say...
any point on this parabola. So let's start with it. Since we're talking distance, we're going to use distance formula, which is d equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay, now, this xy can be one of my coordinate points. It's the distance between xy and 0, 0. So I can just say x minus 0 squared plus y minus 0 squared. That's not a problem, is it?
No.
No.
What was that thing?
Trick question coming up, just so you know. Now, x minus 0 is x, so that's x squared. Y minus 0 is y, so that's y squared. Now, if I have the square root of x squared plus y squared, I can just cancel out the squareds with the radical, right? No. Never, 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 never. That would be the same mistake as distributing this exponent. You cannot distribute an exponent when there is addition or subtraction in there. It's one of my pet peeves. I rip kids to shreds on partial credits when I see this. You may not distribute an exponent when there is addition and subtraction in there. It's all multiplication, then you can distribute it. But you can't here. So this has to stay like this. Unfortunately, the reason why we're not done here is because it said to get this in the form of d of x, a function of x.
So do we have to solve for y?
If only there was something on the board that gave us a hint of what we could substitute in for y.
I know.
Johnny, what would that be?
X squared minus 8.
X squared minus 8. Y equals
Oh
x
my
squared
God,
minus 8.
310.
Now, slightly more important point on this. Johnny just saw that, so he's quick to notice patterns, and
What's on the board?
yes, and this is the correct answer. But I want to bring up a more important point, and it's a little more subtle, okay? This statement here, d equals x squared plus y squared, is a distance formula that will tell you the distance from the origin to any xy point you can imagine. There's nothing in this statement to tell me that this point has to be on the parabola. But once I substitute x squared minus 8 in for y,
Now you do.
that's a limiting factor on the y. That means for whatever x you pick, the y value has to be the corresponding y that's on the parabola. So this accomplishes two things. One, it gives us our function in terms of x, and the directions say we're not correct until we get here. And two, until you put this x squared minus 8 in, you're not locking your distances to points on this parabola. This statement here, again, is the distance from the origin to any point out there. This statement, because of the x squared minus 8 in place of a y, is the distance from the origin to a point that has to be on that parabola. Okay? That's another problem that comes up a lot in calculus. This is where we're really living up to our pre-calculus name. And I admit it's a little bit contrived. But a big chunk of AP calculus is manipulating word problems like this a little farther. In calculus, they'll actually ask you, what's the closest point on the parabola to the origin? In calculus, they'll actually ask you, what is the smallest amount of material you can use to build this box? And they'll ask you to solve some of those without a calculator. So that's why I was kind of playing with you, but also that's why I was like, can you guys find these zeros really quick without a calculator?
Yes.
Because the quicker you get with that, easier it'll be. To be fair, the non-calculator AP calculus questions usually don't involve decimals, but they could. Did we go over all of these?
Yes.
Yes, except for 8.
8, didn't we do that in class yesterday, or one just like it?
I'm good for 8.
Let me check.
That's the one that I actually got.
Oh, yeah.
Yeah, they're both linear.
Ugh. I didn't even need to ask for 40.
300 plus 0.7x and 40 plus 0.9x. Those are the answers for 8.
Can I
What?
quickly get something from Ms. Myers then for that?
Yes. Okay, James, I think, cut. All right.
Well, I also need to get something from a classroom.
Okay, hang on a sec. Tonight's homework is more of the same. Start it in class. And I need to check